Hello students, let's begin this course, discussing this course of fluid mechanics by trying to define fluid. What is a fluid? Now fluid is both liquid and gases, and if you contrast this with solid, we can see that there is one feature of it which distinguishes it from solid. Both liquid and gaseous, their molecules are relatively loosely attached to each other, right? And that's why when a liquid or a gas is kept in a particular vessel, it would occupy the shape of that vessel. Okay. For example, if this is a vessel in which I put some pieces of solid material or some solid, right? So this solid which is put in this will not occupy the shape of this, because the molecules of solid do not have that freedom to move away, right? So the molecular attractive force is much higher. They are closely held. The molecules are closely held, so the solids have definite shape. So they can't occupy the shape of the container in which that solid is placed. But if instead of solid, if there is liquid poured in the vessel, let's say some liquid is poured in the vessel, then this liquid will occupy this shape. Okay. Now, but instead of liquid, if we have gas, let's say this is, if we have put gas in this, the entire space, and if you close this here, let's say, the entire, whatever little gas is put in this vessel, the entire size or entire volume of this vessel will be occupied by the gas, right? But this won't be done by the liquid, because the molecular attractive force between the molecules of the liquid is higher than that of the gas. The gas molecules can move freely. They can move freely, and hence the entire volume will be occupied. So one definition we can say that both liquids and gases will occupy or will take the shape of the container in which they are kept, right? This is one definition. But more scientific, more accurate definition can also be attempted. For example, let's say that this is a solid. There is some solid, and let's say and on this solid there is a plate. This is a plate. This is a plate. So between this plate and this solid surface at the bottom, a solid piece is held, and we are applying a force here. There is some force is applied along its surface, along this plate. So this is that force is applied. Let's say that there is liquid here, or there is some fluid. I won't say liquid, I'll say fluid. It could be liquid or gas. So this is the body of the liquid, and again we consider a plate here. So it's a plate on the liquid, and this is our, let's say, liquid. This entire volume is occupied by liquid, and so this is all liquid. Let's say this is liquid, and force is applied over here. Now how would a fluid, I said liquid, but I meant fluid. How would fluid and solid behave under the action of this force? Now you know that intensity of force is stress, and here, since action is parallel to this top surface, so it's shear stress. So you are causing application of shear stress on solid, and here it is fluid. Let's say that we identify 3 points in this solid, right? And we identify 3 points in the fluid. Now when you apply the shear stress here, you will see that these points will not be dislocated. So when we apply this shear stress, in case of solid, these points, these we can say particles, they won't be dislocated. But here these particles will be dislocated. They'll be so here is a shear stress which is being applied. So you will find that after, say, this is at time t equal to 0, they were having this position. After some time, you will see that their position will be changed, right? So these particles will keep on changing their position. That means this entire fluid is undergoing deformation. So we can say that this becomes the definition of fluid. We can say that fluid, when subjected to shear stress will continuously deform itself. Remember the word continuous. It will be continuously deforming itself. Please note that the application is that of shear stress. If I apply the force like this, the fluid, there won't be any change, right? We'll come to that. I mean, when it comes to liquid, liquids are incompressible. So here, what you need to remember is, while defining the fluid, we are considering the shear stress, application of shear stress, and that will continuously cause the deformation of the fluid, and that's how a fluid can be defined. The fluid is the one, when applied with shear stress, will undergo continuous deformation. Thank you.